Hi, I'm Lucas. Our team, the Electronites, consists of 5 very different people with 5 very different work habits. Throughout the course of getting ready for the Codarra challenge, I have been working on the script.
Hey, my name's Josh. I'm the guy behind writing the report for the Codarra challenge. As well as writing a report, I was also one of the main guys working on the flag along with Levi, who I'll introduce later. And I take other classes, like 3D animation, and I use programs such as Maya, because 3D animation personally interests me, and I like to work with robots as well. And I'm also planning on doing a little bit of programming along with Levi. And here's Levi now.
Hi, I'm Melba. I'm our video editor for the Codarra challenge. Our team has put time and effort into the design of the robot, while script and report and programming as well. Lucas, Josh and Philip have been working on the written pieces that left Adam and me with the robot design and programming. The reason I joined Melba's robotics team was to get more of an understanding about robots and how they work and programming and pretty much everything about robots. So far I've liked it and would like to learn how to program better and eventually get advanced that I can work on massive big robots.
Hi, Madam. I'm the team captain, and I chose robotics mainly for the fact that it just interests me. It looked interesting when I first saw it, and it just personal interest basically was the only reason why I chose it. As Josh said, he does the 3D animation course outside of school. I do that with him. We use programs like the Autodesk Maya. It's a really good program. That's another thing that interests me. Practically only the things that interest me are basically just the things to do with computers. And this is our robot. It's still being worked on. It's missing. We haven't got one of the sensors on it just yet, but the current design is built to be sturdy and tidy, and we've tried as best as we could to get it within the requirements, as well as to make it sturdy and able to do everything that's needed for the challenges. Levi, would you like to talk a bit more about it?
Yeah, we chose bigger wheels on the back to be able to get more ground clearance as the motor spins. With smaller wheels they wouldn't get as fast. We built these 2 bars on the front of it to be able to move the block around when we're doing the block maze challenge. And we've got a colour sensor underneath it, which allows us to be able to follow lines like the aluminium strip, which we'll be using for just the maze challenge. So far the program for this robot would be quite a bit hard due to the front wheels, but I think with all our team effort and teamwork that we'll be working together, I think we'd get over the programming and be able to make this robot go really well.
Boss, it's still recording.
What I like about this robot, I actually really love about the robot, is the fact that we haven't gone with the smaller wheels. At first we had designed it, but it was putting too much pressure on it, so it couldn't really have speed for the first challenge, or one of the first challenges. So we've gone with the bigger wheels, so it can support it better. That gives it the extra agility to complete the first challenge, as well as being able to pick up the cube. So we'll be able to program it through the maze and everything. Also, what I like about this design is it wasn't at first a simple design. We've actually had to think about it, and a lot of effort has gone into building it. I'd say, to be honest, this is maybe our second or actually no, 6th or 8th attempt at building this robot, and I can say it's coming along a lot better than others, and I'm really proud of our robot so far.
You want me to?
Hey, this is Josh again. From what I believe in this robot we're building, I believe I could easily program it so it can so it can go through the maze and to reach the end of our flag, and yeah, And I'm pretty proud of Adam Lee for building this robot because he built it to his own specifications through trial and error to see how well the robot would work. He didn't use any instructions at all to build this robot, and if anything failed, he would just change it again, and if this design doesn't work, what we currently have, we might change it around a little bit as well for the competition.
This robot is a complex design that has taken us a pretty long time to be able to build through trial and error, like Josh said. The one thing that I really like about this robot is, as far as we've gone with the complexity of this robot, is it's very easy to be able to fix the problems with it. I think we've pretty much solved every single problem we could think about with the robot, with all the designs. With the robot, it pretty much is two pieces. It's the bottom half and the top half come apart really easily. This allows quick assemblability, and it also allows us to be able to fix problems easy due to how we can pull it apart and access every single area really quickly. Pretty much this whole design is built off top of Adam's head. All of it has been pretty much... Shut up!
Well, the team has been organised on skill sets. I've looked at what they've been doing, and I've asked what they think they're best at, and decided to get them to work on what they are more comfortable with and what they're better at actually doing. That way they can focus on what they can do and can get it done quickly. The quicker we get it done, the quicker we can get it done, and the more we can work. It means the more we can work on it, and the more we can work on it, the more chance of us getting a better shot at the actual competition. One thing that I actually looked about the robot is I looked at the robot and I'd made it from what I could see, and from what I could see at first. And at first I didn't really like the design, but after adding in some of the parts to stabilize it and changing some parts of it, like with the wheels, we changed the wheels from the small ones to the bigger ones so that we could have more room at the bottom as well, and put the wheels in, also because it was actually pushing against the wheels. So we put the bigger ones in so it had more room at the bottom and stabilized it a bit more, so we could actually fit in the sensor at the bottom as well. The design's really been growing on me, but at first I didn't actually like it that well. But it's been growing on me, and I'm actually starting to like it and enjoy it.
Now we're going to talk about the programming aspects of this robot. I think the programming aspects of this robot would actually be quite simple due to how we've got 4 wheels like a normal car. The back wheels would be mainly for turning like a forklift, and the front wheels would be just stability. We've got a light sensor which is tucked in neatly here, which we can move around if we need to. The programming aspects of this are pretty easy, but the only problem is with turning. I reckon we're going to have a problem due to every now and then there might be a little bit more friction and less friction of the front wheels touching the ground. The rear wheels seem to be holding up the robot quite well, which will also give us better movement and stability while we're going around corners in bends in the maze.